Today lecture for design of column biaxial load. You have to see a problem related to biaxial loading of column. Myself, Dr. J. Sagairugan, Professor and Head, Department of Civil Engineering, Rohini College of Engineering and Technology. So data for calculation of biaxial loading. B is equal to 400. The width of the column is equal to 400 mm and depth of the column is equal to 400 mm. So this is a square column with both width and depth are same for this column. And the total load, that is PU, axial load on the member, is given by 1500 kilonewton. Then MUX and MUY. So moment along x-axis as well as moment along y-axis is given by 50 kilonewton meter. Then material properties, that the characteristic strength of concrete FCK is equal to 20 Newton per mm square and Fy is equal to 450 Newton per mm square. First we have to find out the equivalent bending moment. So normally we have to find out equivalent bending moment. The reinforcement in the section is designed for the axial compressive load Pu and the equivalent moment are Mu is equal to 1.15 into square root of mu x square plus mu y square. So that 1.15 into, already we know the value of mux and muy, that is moment about x axis and y axis. Substitute the value here, finally we will get a value of 81.3. This is a equivalent bending moment, 81.3 kilonewton meter. Let us find out the non-dimensional parameter. Before find out the non-dimensional parameter, this non-dimensional parameter and that bending moment axial force will be calculated by interaction curve. Interaction curve is a visual representation of bending moment and the forces. And this curve explains the ultimate capacity of compression when it is subjected to an axial load and moment. Interaction curve is given in SP 16 1980. So first we have to find out the Pu by FCK BD value, that is 0.468, then mu divided by FCK B into D square, that is 81.3 into 10 power 6 divided by 20 into 400 into 400 square, that will be equal to 0.063. Then we have to find out that D dash by D value. Assume that cover D dash is equal to 40 mm. From that we have to determine the value of D dash by D, that is 0.10. Let us take this interaction chart number 44. Compression with bending, rectangular. This is a rectangular section, same cross section. D dash by D already we defined by 0.10. So we have to take this interaction curve and find out the Pu by FCK BD value and Mu by FCK BD square value. So from chart number 44 of SP16, already we find these two values. Using Pu by FCK BD and Mu by FCK BD square, we have to find this P by FCK. This curve, this is a P by FCK curve. We find out the value of 0.06. So next, percentage of steel reinforcement. Already we know the value FCK 20 into 0.06, that will be equal to 1.2. Then AST given here, BP D divided by 100. Substitute the value. Percentage of steel reinforcement is 1.2 into 400 by 400 divided by 100. So that will be equal to 1920 mm square. This is the area of steel. From the interaction curve we find out by using this chart. So AST required is 1920. So provide 4 bars of 20 mm diameter and 4 bars of 16 mm diameter. So ASC provided is 2060, required 1962. This is a provided 2060, distributed equally on all faces with the 3 bars on each face. So percentage of reinforcement, from we have find out that value is 100 into 2000 divided by 400 by 400, that will be equal to 1.28. So P by FCK is 0.064. From the chart, once again we have to refer that P by FCK value and Mu divided by FCK BD square and P by FCK BD square we have to find out by using this percentage of steel rain. That is P by FCK value 0.064. We will get mu x1 divided by FCK BD square is equal to 0.068, and from that we have to find out that moment mu x1 is equal to 0.068 into 20 into 400 into 400 square into 10 power 6. Due to symmetry, that mu x1 and mu y1 both are same 87 kilonewton meter, because this is a square column. We will get the value mu x1 is equal to mu y1 is equal to 87 kilonewton. Then we have to find out the value of PUZ. PUZ is given in class 39.6 in page number 71 of IS 456 2000. The value is given by PUZ is equal to 0.45 FCK into AC plus 0.75 FY into AC. This is the value PUZ. So substitute all the value. Finally, we will get a value of PUZ is equal to 2062 kilonewton. Then PU by PUZ, that is given in class 39.6. We have to find out the value of PU by PUZ. So we will get the value 0.72. From that we have to find out the value of alpha n. So how we can find out the alpha n? When the PU by PUZ is varying from 0.2 to 0.8, the alpha n varying from 1 to 2. For the value less than 0.2, the alpha n value is 1, and the value is greater than 0.8, the alpha n value is 2. So interpolating, we will get finally we will get a value 1.8. So we determine the alpha n value from this relation PU by PU is. Finally, we have to check the safety under biaxial bending. This formula is member subjected to combined axial load and biaxial bending, is given in 39.6. The formula is mux divided by mux1 alpha n plus muy divided by mun power of alpha n. So the value should be less than or equal to 1. So substitute the value of mux and mux1, then muy and muy1 and alpha n. Here we are getting the value is less than 1, 0.736. So the section is safe against the bending. This is a problem related to member subjected to combined axial load and biaxial bending. Thank you.